All right, so we were talking about different stresses that will call things, and how if they were inside the earth with higher heat and pressure, they might do plastic deformation, or if it's on the surface, you might have brittle deformation where the rock layers snap. Okay, but there are three main types of forces that can act on the rock layers. Okay, although they could also act in different combinations, so that would complicate it a little bit. But the first one is compressional. Okay, compressional forces or stresses. Now, compressional stresses, forces, I keep using the word. All right, now, compressional means you have two forces pushing on the rock layers like this, and they're pushing against it toward each other. Okay, so they're pushing rock layers together. Now, what can happen? Well, you can have it where it just folds. If it's down deep enough in the Earth's surface, then it may just make these nice gentle folds. Okay, if they're elastic and plastic deformation, high enough temperatures and heat, then it may do that. However, if it's more brittle, like this bottom one, you can see where the layers just snap and start going on top of each other. Okay, in general, we would say, since they're pushing it together, this one, which would be the hanging wall, is going to be shoved over the foot wall. Okay, because it's pushing it this way. So since it's pushing it together, it's going to push this one up. It's going to slide up above it. Okay, and when you do that, then this would form a reverse fault. Okay, it's called a reverse fault because the hanging fault is pushed up on top of the hanging wall. So your foot wall is over here, it's being pushed up, and it's over the I did that backwards, sorry. The hanging wall is pushed up over the foot wall. Okay, my bad. Alright. Alright, and when it's pushed up over the foot wall, then that is going to be a reverse fault. Okay, now if it pushes and you just have this folding underneath below the surface, okay, then you would have, like on this drawing down here, if the rock layers just fold, okay, then you have these up and down little hills and valleys. In fact, some mountain ranges that have little hills and valleys are caused by this kind of folding. And then over time, the layers on top of it wash away, leaving this behind, and now you have your hill, valley kind of thing. And the tops of the hills if you will, are called the anticlines. The valleys, or the low spots, are called the synclines. So you'll need to know those two words. The anticline. There we go. Anticline is the hills, and syncline are the little valleys down here. Okay, and this is caused by forces pushing on each side, but usually inside the Earth's surface, because there's no braking or so forth, like the reverse fault. Like this one here would be an example of the reverse fault, because the hanging wall is being shoved up over the foot wall. All right. Now, the second kind of forces are called tensional stresses. Okay, that's not the best spelling, but tensional, tensional stresses. Now, tensional stresses, you have these same rock layers, but now this time they're being pulled apart, basically. Okay, you put tension on a rope, you're pulling it. So this is two rock layers being pulled in two different directions. So when rock layers are being pulled apart, okay. Now, in this case, if they were to snap, then since they're being pulled apart, it's still going to snap like this, but now this part is going to slide down, and so you end up with something like this. And so all right, in this case, the hanging wall, which is here, all right, the hanging wall is going to slip down along the foot wall. This would be the foot wall over here. So it's going to slide down, which you can see how that very easily makes a mountain or valley as this starts to break down over time, erodes. Now you have this little flat area up here, and little coming down into a valley, and then you can see how that could form by that. Whereas with the other one, where it's getting shoved up, it might become a mountain range, or top of a mountain kind of thing. You're still going to have low spots and high spots, so it's kind of mountains and valleys. But in this case, you can see how you have like a mesa or a plateau, and then it comes off into the thing here. All right, so this is called a normal fault. Okay, so this would be an example of a normal fault. Okay, where one slips down, the hanging wall slips down and catches on the bottom of the foot wall. All right, and that would be a normal fault. Now, the last type that we're going to talk about would be a strike slip fault. All right, and that would be this one here. All right, and in this case, you have two layers, and instead of being pushed together or pulled apart, they are going to go sliding in opposite directions. Okay, so this one's being pushed that way, this one's being pushed this way, and so they're striking where they hit each other, and they're slipping passing by, like ships that pass in the night. There we go. And so that's what they're doing. They're passing by each other. So they're moving more of a horizontal. So they're moving mostly horizontal, very little up and down movement. Okay. Now, occasionally though, if it's the edges aren't going to be nice and smooth like these here, so it's going to catch on things, and sometimes it's going to stop it from moving. It keeps pushing on it until it builds up pressure, and eventually it'll build up enough pressure that it will jerk and slide on farther down the thing. Okay, and when it does that, that sends out vibrations, which are basically water earthquakes. So most earthquakes are caused not by normal faults or reverse faults, but by these strike-slip faults. Okay, call them strike-slip stresses or faults. Okay, and these strike-slip faults, when they catch, that's where it strikes, but then it slips and it catches or strikes another part that sticks out and it catches, and then it builds up pressure. The longer it stays pushing pressure on there, it's going to build up pressure, and then it's going to have probably a bigger earthquake when it lets go of that. Okay, and so these are very often the type of faults that would cause earthquakes. The San Andreas fault, probably the most famous one that we usually hear about on a regular basis in California. Okay, and on the coast of California, you have one moving this direction, one moving that direction, and because of that, every time it slips on there, it causes some very large earthquakes in California and along the coast there. All right. Well, and that's it for chapter 26. Chapter 27, we'll move on to plate tectonics.